My name is Hugo Kornelis, and I make SQLServerFast.com, which is a website that I built up to that I created so that I could build documentation of execution plans there. Microsoft does a lot of things good, or one thing is severely lacking, and that is documentation for execution plans. And then I decided when they won't do it, let me handle it. And that's where the execution plan reference was born. Now, a reference is not a good teaching place. So if you want to learn, you can use the execution plan video training, um, which is a series of in-depth training courses where I teach you everything I can about execution plans, part of it for free, part of it for a moderate price. And there's something wrong in my animation order there. Let's pretend that this actually appeared, that already moderate price can be reduced in two ways, or actually three. One is to use the limited time offer valid for the rest of this year with the code WA2024 to give you a 10% discount. The other option, if you are fast, then you can go to my pre-con, which is next Tuesday in Seattle at the Past Data Community Summit, or in the future at another delivery of my pre-con, and then you will get a 20% discount code that doesn't expire, and that is also
Hugo,
valid
are
for
you
future videos.
are you
Yes,
sharing anything? All we
I
can see
am
is
not
your.
sharing my screen. Oh my
You
dear
just have to
Lord.
imagine what the code is,
Yeah, let's share my screen so that you actually know the code.
and
Eugene,
then
the participants are saying they can't see, they can't type in chat, so you want to look at settings for that.
I do not think I got promoted to host, so I I would say Blythe if she exists, or you if you're able to poke at it is probably our best bet right now.
Okay, I'll poke around. I'm not going to interrupt you. Let's
Yep,
go.
Okay,
I can interrupt him just fine.
so now you see the code on the screen, 10%
Yes.
limited time WA 2024, or attend my pre-con, and at the end of the pre-con, everyone who survives a whole day of me will get a 20% discount.
Okay.
And if you time it smartly, in a few days, it's November, and the whole month of November is in America a single Friday, Black
It's
Friday.
true.
During
It's our
November,
national holiday.
I give a 50% discount on all my videos, and that stacks with those codes. So you get a very good offer here if you want to see those in-depth training videos. Let's make sure the right screen has focus again. So that is on SQLServerFast.com. You can also find a link to my YouTube channel. You can find my blog there. But the most important thing that you will find there is the resources link. So if you go to my website, SQLServerFast.com, then in the menu, go to Other Presentations and Presentation Resources. What you will see is a long list of all my conference talks. Each of them is a link, goes to a page with a short description of that talk, and a download link where you can get a zip file with the demo code and the PowerPoint slides I use for that talk. All available to you at no cost at all. Just go there and download. So that will, for this session, mostly be demo code, because this is actually a demo only session. I have just a few slides to set up what we're going to do today. Let's jump into that, but first let me add that if you have a question that that you don't get answered within this session because we run out of time, or because perhaps the question only pops up later, or perhaps you're watching this later on YouTube. I think this will be posted on YouTube, and you have questions, just mail me or tweet me. These are my contact details. I normally always respond. Sometimes I'm a bit busy. Mails can get swamped. I'm not ignoring you because you are you. I'm ignoring you because I am me and I am busy. So just send me a reminder a week later or so if you still have no reply. Hey Hugo, I sent you a mail last week. Did you get it? And did you already get to it? Simple, sweet, and you will get your answer. So this talk, The whole idea of this talk is based on a gap in how we generally teach execution plans. So what normally happens when people like me and others like me teach execution plans is that we get in front of a classroom, real or virtual, like we do now, and we present a nice and clean, simplified example that highlights exactly what we want to talk about. And then we give you all the information we can about that specifically cleaned up example, which works great to give you an understanding. So you are like, oh, now I know, now I understand. This was a very clear explanation. And then you go back to your workplace the next day, feeling all giddy because you have learned so much and now you know execution plans. So your boss says, go to your coworker. She is having a problem right now and she might need your help. So please go to her and help her. You go to your coworker and she said, oh, you're right in time. I have this performance issue with a query. And you, full of confidence, are like, okay, show me the execution plan. Sure, here it is. Oh,
It's
now
fine.
what? This is not what Hugo taught me yesterday. And then you are stuck because you don't know how to handle that. So we need something to bridge the gap between those very nice and clean execution plans that we normally use in the classroom and the messy reality of your real world queries and execution plans. And that's what I try to do with this session. So what I do is I have created some sample queries, which will result in sample execution plans based on realistic scenarios. Not real, they're still adventure works, they're still made up in my mind, but they're realistic, based on what can happen in reality. I made them of medium complexity, so in between those two extremes. And for that, I have created 3 use cases. Now, I know that to go through all 3 use cases takes at least 75 minutes. I have 60. So what I will do is I will start with the excessive I/O. And normally I would do a show of hands when I'm done there, but that's not practical because I can't see anyone. So perhaps people can already start dropping in chat whether they want the second example to be about high resource semaphore weights or about erratic query performance. I will do one of those two depending on what the majority asks. Now, if your favorite one is not chosen, or and by the way, Mala, I will ask you at the end of the first example to give me the winner. So that's an
Okay.
extra task for you to keep count of the votes. If your favorite isn't chosen, or if you want to review it later, you can go to tinyurl.com/HugoConf, short for Hugo, my name, and then conference. Easy to remember. That brings you to my YouTube channel where you will find 3 videos called Here's the Execution Plan, Now What? Part 1, Part 2, Part 3. Each of them is for one of those 3 cases, so you can review them or you can view the one we didn't get to today. But let's get started. Let's look at the first example where we have to deal with excessive I/O. And let's jump to Management Studio. Like I said, these scripts are also available from my website if you just download the zip file archive, so you can later play with it yourself. And as you see, I have a setup script where the contents should not be shown during the presentation, so I will not show the contents, but I already executed it so that everything is set up and I can do my demo. Like I said, the first problem is excessive I/O. So perhaps you are a DBA and you have identified a store procedure that causes excessive I/O and you need to fix it. Or perhaps you are the developer and your DBA is at your desk fuming because you are responsible for fixing a store procedure with that excessive I/O. Either way, you know the store procedure, you know the problem, you need to fix it. Let's first make sure we're in the right database. And But what we can do is just run the query to see what's happening. If I execute it, you will see that it completes very fast. Well, the problem wasn't the speed of this store procedure. The problem is that it causes too much I/O. So yeah, seeing that it runs fast doesn't really get me anywhere. But looking at the results, I do now have a vague idea of what the store procedure does. It's more important and more relevant to see how that works. So I'm going to search for the store procedure, sales by regions. That is this one. And now I'm going to spend approximately 2 minutes to save you 1 or 2 seconds in the future, but multiple times. So what many people do when they want to see the text of a store procedure is right-click, script store procedure as create to or alter to or create or alter to new query window. That's 3 hovers or mouse clicks. I can save you some time by doing right-click, modify. And instantly I get an alter procedure script. Modify is the same as script as alter. Clicking modify doesn't modify anything. It gives me this script. Now, if I now go on to change some text and then execute this, then I have modified the procedure. But I can just use this to quickly see the text of a store procedure. And in this store procedure, I see that there's comments. Hooray! How often do we get that when we are on production on systems that we didn't code ourselves, right? You all always comment your code. I know that. You are the smart people, but our colleagues often forget. So in this case, my colleague actually added comments. Let's scroll a bit so that let's just give myself a bit more room, and now you can see the whole text. And okay, the first thing I see is that there's a comment, but it's perhaps not the clearest. SPSTCR and A dash dash larger than SP dash dash larger than is okay, dash dash larger than will probably be an arrow, but still. However, when I read it fully, we need to join sales order header to address, to state province, to sales territory, to country region 2 times. We also need to join sales order header to salesperson, to sales territory, to country region once. To reduce code duplication and increase speed, we will first do these joins. So this join and this join. And then it says here SPSTCR. Okay, that's short for sales province to sales territory to country region. And A to SP, that is address to that whole stuff. Okay, now it becomes more clear, and we store the result of that in table variables. The join to salesperson then becomes much more efficient. Now I know a bit about how SQL Server works, and I'm not convinced that that is true. It might be, it might not be, I'm not convinced. You might be inclined to instantly change this now, but I don't, because I don't like throwing stuff at the wall and seeing what sticks. I don't know whether this is the root cause of excessive I/O. So I can change this, but then I'm working in the blind, and I like to know what I'm doing. So let's first look further, but of course this is stored in my brain now as something to look out for. Then I see that there's first a joint sales territory to country region. That's not listed above. It's part of it. There's one that starts at state province and one that starts at address. So apparently there's even more done that is not in the comments. Oh, great. Comments that are not completely up to date. We love them, right?
Hugo,
Um,
we do have a question, although I missed it
yes.
because it was in the chat, not the QA. So I don't know if it's still relevant. How do we know which join need to perform first is the question.
How do we need to know which join we need to perform first? We don't. Normally, SQL Server figures that out. And the correct order of working is write a query in such a way that it's easy to understand and maintain, execute it, check performance. If there is an issue, look in the execution plan, find the root cause, and then fix it, which at that point might result in changing join order or stuff like that. but we don't start by forcing a join order. We only worry about join order when we see a problem caused by join order. I hope that answers the question.
I think so. Yeah.
So we have this table sales territory to country region name, and indeed we fill it by a join from sales territory to country region name. And then in the next step, that table is used to complete the salesperson to sales territory to country region. So that's why this intermediate step was done. And then we have also address to state, province to sales territory to country region. And you might expect that sales territory to country region is used again, but it isn't. Another mental note is that something weird has been going on here. Someone has overlooked an opportunity or changed something, but not completely. It's not consistent. So let's keep that in mind as well. This is all preparation. And then after all that preparation comes the actual query, where we select a color and at the end we aggregate by that color. Well, we saw that in the results, right? List by color. And then we have several aggregates. How are those computed? Well, we start by joining sales order header and sales order detail, very standard in AdventureWorks. Join that to the product table, and then we join to the table variables based on the bill address ID, the ship address ID, and the salesperson ID. And we have a filter where the bill region has to be a value passed in, the ship region has to be passed in, and the salesperson region has to be passed in. So we don't filter by ID, but by the name. And again, we saw that here when the procedure was called, because we say all of the 3 regions have to be the United States.
Yeah.
So we have
We've
a
got
total.
another
all the sales.
question.
Let me finish, please.
Yep,
At the
yep.
end of my sentence, we
Yep,
have
say
a total. No, it's okay. We have a total bicolor for all the sales built to the United States and shipped to the United States and made by someone in the United States, where we have these 4 aggregates. Okay, your turn.
Yeah, yeah, no worries. Srinivas, actually, now I got 2 questions. Srinivas asks, is it okay to intersperse declare statements between select or DML statements? Does it recompile table variable index to be created with primary key constraint?
That does not result in recompiles. The location of declare statements, if it's just a declare, doesn't matter at all, because declare statements for a SQL Server always parses the whole batch, interprets the declare statements first so that the variables are known, and then interprets the rest.
Got
Even
it.
if a declare statement is in an if-then construction, the variable will always be declared regardless of whether it executes or not. If you
And then,
combine declaration with assignment, declare at I integer equals 0, then it's basically a combination of a declaration and an executable statement. It's just a shorthand for declare at I int, the semicolon, set at I equals 1. And that the assignment statement is executed, but the variable assignment does not result in recompiles.
awesome. And then the other question that popped up, can we just eliminate the table variables and join to the tables directly?
That is what I was alluding to when I commented here on this statement that this becomes much more efficient. I don't know whether that is true. I actually created this myself, and I actually never checked whether it is true or not in this case. I am not at all convinced that this is always better. I didn't check for this specific example because this example just does what I wanted to do. And you will see at the end that this eventually remains the same and will be added on our to-do list for later to look into it. But right now, I'm solving an urgent problem with excessive I/O. So I really want to know where the excessive I/O comes from, then solve that. And if there's other issues, then those can wait until later because I have some urgent tickets on my desk right now.
Right. Okay, that's it.
But that question or comment is actually exactly what I was alluding to. I am not convinced. Look, for the record, it does simplify the query. If I don't use the table variables, then this query becomes like a 10 or 15 table query, and it becomes a monster to understand. So I see a reason to do it. It's just not performance. and it might be good for performance, it might be bad for performance. The only way to know that is to test it. Good, let me continue. I have seen the stored procedure, and I now also understand the results a bit better. But seeing the stored procedure, yeah, we saw some red flags, and not red flags in the sense of this is always bad, but suspect things. But we're still not sure. Now, this is a talk about execution plans, so why didn't I look at the execution plan? What Microsoft calls the estimated execution plan is actually just the execution plan. So let's look at the execution plan. And if I look at the execution plan, what I see is basically a bunch of execution plans tied together in a stored procedure operator that each do one of those statements. And I can look at this and nod and appear very interested, like, oh yeah, I see what's going on. But what I don't see is where the excessive I/O is. To do that, it's much better to actually execute the stored procedure with the option set statistics I/O on, and I add set statistics time on for good measure. So let's execute this, and now we get the results, and we get an overview of the I/O that was done. Now this is very readable and easy to parse. No, it isn't. So time for the next trick. I hit Ctrl A and Ctrl C to just put all this text in the clipboard. Then I go to a website called statisticsparser.com. This is created by Richie Rump, for which we should all be very thankful. You don't have to register, you don't have to leave your email address, you don't have to pay, you don't even have to watch an ad or ignore an ad. It's completely free. You paste the text there, Ctrl V, you click parse, and you get the same information neatly organized in one table per statement. Each of those tables can be sorted by every column just by clicking it. Each of those tables has a row with totals, and at the end there is an extra table with the totals for the entire stored procedure. All this information very easily accessible. A great tool. Now, if I go through the statements, I will see that the first statement is 32 logical reads. The second is 70 logical reads. My problem was excessive logical reads, excessive I/O. So guess what? 32 and 70 are not the statements that cause me issues. Here, the third statement has almost 20,000 logical reads. And that might be interesting until you look at the fourth statement and see that here there's over 170,000 logical reads. If I want to reduce the logical reads by this stored procedure, I need to focus on the fourth statement. The first and the second don't do anything. Even if I can get them to 0, which is of course impossible, then I still saved only 20 or 30 IOs on a total for the entire stored procedure of 190,000. I need to do some work here. Even working here will not save more than a few percent. So let's look at this statement, and by sorting on the logical reads columns, I can immediately see that the biggest offender is a work table, 78,000 logical reads, and almost as many, 76,000 logical reads for the product table. The other tables are once more basically rounding errors. Those almost 160,000 logical reads of these two combined, that is where I need to do work. So let's start with the product table. I'm going to execute the query again, but now I'm going to enable the execution plan with runtime statistics, or which sometimes confusingly is called the actual execution plan. Remember, there's just one execution plan. Estimated and actual execution plans are the same. We have an execution plan, or we have an execution plan with additional runtime statistics. And those, of course, can only be collected if you execute the query. So I'm going to execute the query. And now I don't only have results and statistics I/O, I also have the execution plans, and we already saw them when we looked at the execution plan only. We see the same execution plans here, but now with those runtime statistics. When you look at these execution plans, you might see that query number 3 is listed as being 70% of the batch. So if you hadn't looked at the statistics IO and you would have looked only here, you would have been misled into thinking that query 3 is the big problem. It isn't, at least not in IO. We saw that, and I can assure you, if you look at statistics time or memory usage or whatever else, this query is not the problem. This is misleading information. The information you see here is based on estimates. And when you need to look at a badly performing query, it's almost always related to bad estimates somewhere. And then you are looking at something that is measured based on those incorrect estimates, so you get an incorrect result. Query 3 SQL Server, the optimizer, thinks it will be 70% because it thinks query 4 will be relatively cheap, but SQL Server is wrong. And that is exactly why query 4 is so expensive. So if I look at this query, I see table spool operators, multiple of them. These two, and then three more here. Those create IO in TempDB. That is the work table we saw. I also see triangles, warning symbols. And if I hover those operators, I will see that this means that the operator had to spill to TempDB. Now you might think that's also the work table. No, spilling to TempDB is not recorded in the statistics IO output. You don't see that. You definitely don't see the writes. So, and often also don't see the reads depending on what kind of spill exactly is used. In this case, you don't see any of the IO on the spill. So that's even more IO that we didn't even see, but it's there. We wrote 286 pages and read 286 pages for this sort operator. For this sort operator, another 8 pages written and read. And for this operator, another 64. Okay, the numbers are not very high, but it's still an extra IO. But I said that I wanted to focus on the product table first. So let's move further to the right. And here I see that the product table is read in this clustered index seek. Now there may be multiple operators that access the same table in the execution plan, so I shouldn't immediately jump towards this operator. So let's review the rest. Here we read sales order detail. Here we read a table variable. Here a table variable. Go further to the right and down a bit. Here we read a table variable. Here we read sales order header, and here we read sales order header. So now I know for sure that, oops, sometimes scrolling doesn't do what I want, that this clustered index seek is the only operator that causes IO on the product table. And it was 76,000 IOs, if you remember correctly. Now, why does this clustered index seek cause so much IO? A clustered index seek searches through the binary tree structure of an index to quickly find the row we want. That is usually 2 or 3 IOs, not 76,000. What we see here is that there are 38,000 executions. And at 2 logical reads per execution, yeah, that's where we get to 76,000. Now the product table isn't even a large table. It has 504 rows. To have 76,000 IOs on a table that has only 504 rows, and I think 8 or 10 or so pages, if I remember correctly, you have to work hard. And you can do that by executing a clustered index seek 38,000 times. That's not smart. A scan would have been much better. So why didn't SQL Server choose a scan? Well, that is because SQL Server thinks, let's make sure that you can read it, that the number of execution will be about 4. And if you do just 4 executions, yeah, then it's 8 logical reads. That sounds good. So the problem is Well, the problem is that there is a clustered index seek, but why is there a clustered index seek? Because we have a bad estimate, because SQL Server thinks there will be 3.8 rows, and in reality it's 38,000. So then the next question is, why does SQL Server have this large misestimate here? Because if I want to fix this, SQL Server will always pick a seek when the estimate is 4. So I need to get a better estimate. That means I need to know why we have the bad estimates. And we can check them. Here, I don't even have to hover. You see the relevant values here as well. The actual number and the estimated value. So if this estimate is here, the number of executions of this clustered index seek, because this is a nested loops operator, is determined by the number of rows produced by this nested loops. And indeed, here you see those same values, but now as the number of rows. In reality, 38,000, estimated 3.8. These numbers of rows resulted in the number of executions on the bottom input. Okay, so why do we have this bad estimate here? Well, you can see that the same bad estimate basically also exists here. Okay, it's multiplied here because the sales order detail adds extra rows for each input row, but we start with an estimate of 1 and we multiply it by 4. We have a reality of 24,000 and we multiply it by, what is it, 1.5 or so. So why do we have an estimate of 1 here? And here you see where it all starts. Here you see estimates of 1 over a reality of 8,600. And why do we have those estimates of 1 here? Because we use a table variable. Table variables, due to their nature, always have an estimate of 1. Okay, there are some rare exceptions. I'm not going into that. Normally, you always get an estimate of 1 on table variables. This has improved in newer versions of SQL Server. Now you can get different kind of problems with table variables. But in the version I'm using to demo, that's part of what was in the script that I didn't allow you to look at. SQL Server couldn't fix this. SQL Server always had this estimate of 1 with table variables. So how can we fix that? Well, instead of table variables, we can use temporary tables. They are not without issues either, but they do have a better estimation of their cardinality. At the price of introducing perhaps new problems, I'm going to fix this cardinality issue by changing one thing. All the temporary table variables are now temporary tables. And that's the only thing I changed. I didn't change anything else, not even the things that I might be inclined to change, because I'm always certain that they will improve the performance. And the reason I'm making only this change is because if I have a baseline, do one change, and I measure again, I know exactly what my change did. If I have a baseline, do 2 changes, and then measure again, I know nothing, because I don't
Quick
know
question.
which of the changes caused that change in results. Yes, what's the question?
What compatibility level are you running in?
I think 130. I can check that by going, 140.
Oh, perfect. Okay. Awesome. Thank you.
Let's restore these. I will need them later anyway. So I have this new version of the store procedure that uses temporary tables instead of table variables. And now I'm going to run the store procedure again. And once more, I'm going to look at the statistics row, or rather, I'm not going to look at it. I'm going to dump it in the statistics parser. Sometimes I even use a second window so that I can use them side by side. Now I choose simplicity. I just look at the new data and instantly go to the totals. And I see that the total of the entire store procedure has indeed been reduced greatly. It was almost 180,000. Now we're at almost 90,000. And if I look at the fourth statement and sort by logical reads, I see that the work table is still there, of course, but the product table is now down to just 15 logical reads instead of 76,000. So we achieved a lot, perhaps even enough. And if we achieved enough, then we should stop working now, because there's more other important tickets. There might be more possible with this store procedure, but perhaps it's already good enough. Let's pretend it's not good enough yet. So I executed this already with the execution plan with runtime statistics, and you will see that the first, second, and third execution plans are unchanged logically because the code is the same, except that I now insert into a temporary table instead of a table variable. The fourth statement now is estimated to be more expensive. But I'm happy that it's estimated to be more expensive because SQL Server no longer thinks that those tables have one row only. And if I go to the right, I will see that indeed SQL Server now estimates correctly how many rows there are in those tables. So yeah, the estimated cost of processing this is higher, but the result is that we get a better execution plan and that the actual cost will be lower. Once more, those percentages can be very misleading. I also see that indeed that clustered index seek on the product table is now gone. We simply have a clustered index scan. I also see that as a kind of a bonus, I got rid of one spill. This sort no longer spills. This sort still does, and this sort still does. So they're still spilling, but less. But still, I don't like spilling. Spilling causes I/O. I already mentioned that. It also slows down the query, not the issue I'm solving now, but if I can hit two nails with one whack, then why not? So the next question is, why do we have those spills? A spill of a sort means that SQL Server underestimated the storage space it needs to store the data it wants to sort. And you can see here why. This table spool produces 38,000 rows, but SQL Server thought it would be 1,500. So the amount of memory reserved for that sort is based on 1,500 plus some margin, but not enough margin to cover 38,000. The estimates are better, but still too low. We still underestimate how much work we need to do. Now, why does that happen? And again, you can look at all the numbers on the screen, and I'm going to instantly zoom to where the bad things happen, and that is here. So SQL Server reads salesperson to country, and here we already have an extra filter on it has to be North America. The same happens here in this table scan on address to country region name, and in this table scan. So all of those joins not only add data to the rows, but also filter. And that is why SQL Server says, okay, I have 31,000 rows in the sales order header table. But when I filter that on salesperson to country, then it goes down to 1,895. To 1,895. And then if I add the filter on address to country region, it goes to 859. And if I filter again, it goes to 390. In reality, we see that this first filtering reduces from 31,000 to 2,500, and then the number doesn't reduce anymore. Now, to understand this, you have to know a bit about how SQL Server estimates multiple predicates. And SQL Server has two ways. One is to assume that predicates are completely independent. Person is Dutch, person is male. Yeah, that is independent. 50% of Dutch people are male, 50% of American people are male, 50% of Brazilian people are male, etc. There is no correlation there. Or we can have partial correlation. Person is Dutch, and person has seen windmills in his life. Tourist information isn't always completely accurate, but yeah, the Netherlands has a rather high percentage of windmills, mostly preserved for tourists. But as such, relatively speaking, more Dutch people will have seen windmills than American people or Spanish people. but it's not a full correlation. There are American people who have seen windmills. There are Dutch people who have never seen windmills. So that can happen. There we have partial correlation. And then we have full correlation. Lives in Amsterdam and lives in the Netherlands. Yeah, if someone lives in Amsterdam, then he will live in the Netherlands. There's no way around that. That is full correlation. In our case, what we are doing is built to the United States, shipped to the United States, and sold by someone who works the United States. Those are not technically fully correlated. There might be exceptions where they are different, but in most of the cases, this is nearly full correlation. Now, SQL Server can do estimations based on two assumptions, depending on which version of the cardinality estimator you use: no correlation or partial correlation. Full correlation is not possible. So I can change the version of the cardinality estimator, but it will be only more wrong. I cannot change to a version that is better. So I can't fix this, right? Well, of course I can. I just need to work around SQL Server's limitations. So what I do is I realize, okay, basically this whole part until this hash match, that I will not be able to get better estimates here, but I can break off everything here. Do this first, store the results, and then in the next step, I have a better estimation. I do that by breaking the query in two. So the start of the store procedure is still the same, but now I create an extra store temporary table. And for that extra temporary table, I'm going to just find the sales order ID and the subtotal as well when I add it anyway from the sales order header table by only joining to the other temporary tables and selecting. I don't do the rest of the query yet. And then in the actual query, I use the selected sales order headers to join to sales order detail and product and do the aggregation. So I split query number 4 in two new queries, query 4 and query 5.
Some questions before we get on to the next part real quick. We got 3 of them, so people are definitely engaged.
Yeah.
First one, does it help to improve performance by creating indexes on temporary tables?
Sometimes yes, sometimes no. You would have to test.
Okay. Is it recommended to convert table variable or temporary tables to memory OLTP table with schema only option?
In most cases, I would say yes.
Okay.
But as always, there might be exceptions, so test it.
And then the last one, does the memory grant feedback feature help with the memory grant issue?
Yes, if the same query is executed multiple times, then that will help. In this case, I don't have column store indexes, so it's a row mode plan. So I would need to be on at least SQL Server 2019 to get memory grant feedback. But if I did, yes, it would help.
Okay, perfect. Thank you.
So I changed the store procedure. I'm going to execute it. I'm going to look here and let's just paste it again. New version, parse. And now if I go down to the bottom, you see that the number is slightly lower. It was 89,000, it is 85,000. That is not even an expectation I had because I was actually fixing those spills. And if you look, you will see that in the 4th query, I still have this bad estimate. The same numbers as before. Like I said, I can't fix that. But in the 5th query, where the selected sales order header tables is now used, it uses the actual number of rows that is there. And then with further joins, we still see that estimates are not entirely correct. You never get estimates entirely correct. Joins are incredibly hard to estimate, but they are low enough. The error is now small enough that we don't get spills anymore. Nothing spilled, no warning symbols anywhere in this execution plan. So that is not in statistics IO, but we reduced those IOs. And as a bonus, we got some other join types somewhere which also optimized some of the other I/O, which actually gave us an extra bonus. And that is also a reason why you always should do one step at a time and test, because unexpected changes can give you a bonus, but they also can hit you hard. So always test, always check. Now, there's one large I/O part still there, and that is this table spool. This table spool with its counterparts is needed because in the query we use multiple count distincts. To do a count distinct, what SQL Server does is, if you want a count distinct product ID, it removes all the duplicate product IDs and then counts the number of rows remaining. Yeah, grouped by color. For the count distinct sales order ID, it wants to remove all duplicate sales order IDs. But we already removed a lot of rows when we removed the duplicate product ID, so we don't have the original data anymore. And we might miss sales order IDs now. And that is why we get an execution plan that uses a table spool to store a copy of the data. Now we can reduce the set by removing duplicates. And then in the next branch, we read the original table back from TempDB. Now, I'm not saying it's impossible to get rid of this if you functionally actually need those count distincts. But if you actually need them and you need to reduce the I/O even further, then it will be a very difficult challenge that I consider beyond the scope of this talk. So let's assume that the number of I/Os we now have left is low enough that the DBA is happy that this store procedure doesn't cause problems anymore. And then let's click the right button. In the comments, I say, like I said, I saw some stuff in the store procedure that I found suspect. I would add backlog items for those. Perhaps one day I will have some free time to go through the backlog and make this store procedure even better. But the immediate problem is solved, and we need to get to the next immediate problem, because that is more urgent. Mala, did you have a count of whether we're going to talk about high resource semaphore weights or whether we're going to talk about erratic query performance?
The
We
winner
did.
is erratic query performance, Hugo.
Good.
And you've got about
It
10
was
minutes
really
left.
neck to neck, though. Very close.
Oh, cool. Yeah, it's often neck and neck. And I know I don't have much time. I have 12 minutes actually. Eugene, don't
I'm
rob me of my
sorry I
minutes.
rounded. I apologize.
So we have a store procedure that is used to find the orders of a customer. And as often when we need to find those orders, we don't know in advance which parameters the person on the phone is going to give us. So this is the kind of store procedure that has countless optional parameters. And let's just look at the store procedure to see what's happening. So thanks to a SQL prompt, I'm going to quickly type in some random data. Let's just supply some. I happen to know that this is year date. Let's just supply some values. Well, let's also add a product ID, and now we have a possible way to execute this store procedure. And let's look at the execution plan as well. So if I look at the execution plan, I see that this is the execution plan. Okay, fair enough. But I actually skipped a step. Sorry for that. And I should have read my own comments because there's a reminder in here. If you have a query with erratic query performance, then a great tool to find the problem is the query store. I'm not going to talk in detail about the query store, but the queries with high variance is a place where you can typically find those queries that have erratic performance. And yeah, there is a query here, but that's not the one I want because the default configuration is a bit stupid. Let's base it on standard deviation. And now I still don't get the query I want. And that is because this is last hour. And it is, I set up this demo 1 hour ago, so that was the previous hour. And now I get the query I wanted to see. Yes. So here we see a query where if I look at, first I see that there's multiple execution plans. And if I look at one of those execution plans, I see that the minimum duration and the maximum duration are far apart. And if I look at one of the other execution plans, I see the same. And once more, I see the same. Each of those has a very low minimum duration and a much higher maximum duration. And of course, a few hundred milliseconds isn't really a problem. This is a demo on a small database. You can understand that this might become a bigger issue if you have way more data. Now I see that all of those execution plans have a plan shape that use a clustered index insert on the left. And that's weird because when I just ran the query, I had an execution plan with a hash match on the left. And that's all there is. But the issue was with find order. So what's going on here? Well, what's going on is that I forgot to first look at the text of the store procedure. So let's do that. And if you look in this store procedure, you see all those optional parameters. And then you can also see that there is an if here. If sales order ID is null, if sales order ID is not given, then we have a step where we declare a table variable and put data in that table variable based on this pattern that you probably have seen for store procedures like this. Either the order month is null, we didn't specify one, or the order date in the data equals the order month we have given. And the same for salesperson, the same for customer ID, the same with a subquery for product ID, and so on and so forth. So all those search parameters are then used to find the sales order IDs that we want and put them in a table variable. Then, and this is outside of the if loop, so this is the part we always do, we read from the sales order header, we cross-apply some aggregation, we join to the customer and the person and the salesperson table for all the details we want here. And we do that based on a where clause where either the sales order ID equals the value we specified, or the sales order ID exists in the table variable. So if we skipped the if because the sales order ID was not null, then this part becomes not invalid, but it doesn't do anything because the table variable is empty. But here we select the single sales order ID we passed in. If we didn't pass in a sales order ID, then this part will do nothing because no sales order ID is equal to null, but this part does the actual selection in combination with this step before. Okay, so I supplied some random parameters and one of them was the sales order ID, and that's why the first query was skipped. So what I could do instead is go to the floor or where the people work and ask them, give me a recent example. And then they will tell me, yeah, we currently are having a problem with this version. So if I execute this, I can see in the messages if I enable statistics IO. So let's quickly do that. I can see in the messages that there is a lot of IO on some tables. At least there should be. My demo is failing at this point. I don't know why. I'm not going to figure that out. Normally you will get some very high numbers here. What is happening here, and you should be able to see that in the execution plan, though probably that fails as well now. If you go to the top left operator and go to the parameter list, you will see that for some of those parameters, and let's find if there's any here. No, it doesn't happen this time, but what you should normally see is that the parameter compiled value and the parameter runtime value are different. Let's see if I can show an example of that by going off script a bit and doing a different version. It's happened for the second time now that this thing went wrong, and in between it always goes right. So I don't understand why it sometimes goes wrong. Let's see if I get it to show now. And no, it doesn't. So I don't know what's going wrong. I'm sorry. Normally you will see a different value for the parameter compiled value and the parameter runtime value. That means that an execution plan was created for some parameters, With parameter sniffing, that was cached, and then when you specified other parameters, that old execution plan is reused. So I'm running out of time, so I'm not going to spend a lot of time, but there on bad parameter sniffing. But I call it bad parameter sniffing, not parameter sniffing, because parameter sniffing in itself is good in many cases. But sometimes it turns bad in specific combinations, mostly when you have queries with equality on a very skewed column, like for instance the list of subscribers to a local newspaper in Amsterdam. There will be people outside of Amsterdam who also subscribe, but there's limited number. Most subscribers will be in Amsterdam, so you have a very skewed data distribution. If you then filter on the city, you might get bad parameter sniffing. Another big issue can be inequality searches. Find all the sales since a certain date. Usually we do week to date or month to date, which is a limited number, but once in every while a manager asks for everything in the past 3 years. And then we have far more data. So there also you can get bad parameter sniffing. And the third typical example of bad parameter sniffing is literally what we're looking at now, optional parameters in store procedures, because you get an execution plan for parameter combination X, and then you execute it with parameter combination Y, which is, it will still give you correct results, but the execution plan isn't efficient anymore. So the simplest way to fix bad parameter sniffing is to force a recompile of the query. And that is actually, not all experts agree, but for me, that is my go-to method. I only avoid this method if the query is very expensive to compile and executed often enough that that causes an issue, or if the query is normally expensive to compile and runs basically thousands, hundreds of thousands, or millions of times. Because in those cases, you get too much overhead for all the recompilations. Then you need to look at the other ways, like optimize for unknown, like splitting in separate store procedures, or using dynamic SQL. But if you do that, be very careful about SQL injection. Check the website that Erlen Sommerskoek created about the dangers of dynamic SQL. In this case, what I'm going to do is create a new store procedure for the specific case that we entered the sales order ID. And then we don't need the table variable at all. We only filter on sales order ID equals sales order ID. The second one, for the remaining 6 parameters, there I use dynamic search. And as you see, I don't concatenate order month here. I don't type this. That would enable SQL injection. But by using add order month as a constant, and you will see that all the code, everything I add in query is string constants. No user input at all goes into add query. And then the parameters are still regular parameters for SP execute SQL. And that is how you prevent SQL injection. And then we can also return the data. So now we have 2 versions of the store procedure. To make sure that we don't need to change anything in the front end, the original store procedure is now dropped and recreated using a if-else, where I call one of the 2 new store procedures. And the result is that now everything will run efficiently. I'm not going to show the execution plans in the statistics IO, but you can do that later if you work with the demo code yourself. Where an option recompile would cause a recompile every time the store procedure runs, this version only causes a recompile or a new compile for a new combination of parameters. So if I use one with sales order ID and customer last name that I also used here, we don't get a new compile. We still get the old compile based on other parameters. And I hope that this does work. Yeah, now it does work. Now you see that indeed there is a difference between the compilation value and the runtime value. That means that you still can get bad parameter sniffing by the other reasons, skew or inequality searches, but then you have to fix that as well. But the problems caused by the optional parameters are now fixed without having to recompile the procedure every time. One compilation for each unique combination of parameters, not more.